Hello everyone, welcome to Tech Wizards. In today's video, we will explore one of the most fundamental concepts in our programming, that is data structures. Whether you are doing basic statistics or advanced machine learning, understanding data structures is absolutely essential. So let's get started. What is data structure? A data structure is simply a way to store and organize data in a program. Data structures allow us to work with the data in an organized and efficient way, whether it's a single number, a list of names, or a whole dataset. So in simple words, data structures help us to store a number, to store a text, or even more complex types of data. Without proper data structure, it would be very difficult to analyze or process data. So understanding these structures is foundational for doing anything meaningful in R, such as analysis, visualization, modeling, or training a machine learning model. So all of these required a concept of data structure. Now let's talk about types of data structures. Broadly speaking, R provides two main categories of data structures. The first category is atomic data structure. These structures can only hold elements of the same data type. This includes vector, it will be one dimensional, matrices, two dimensional, arrays, multidimensionals. All of these atomic data structures are homogeneous, meaning all values inside them are of the same type. Like all will be numbers or characters or text, anything. The second category is non-atomic data structures, which allow mixed data types. So these includes list, which can store numbers, strings. As you know, strings are text. Next is data frame. In data frame, each column can have a different type of data. And the last one is the factors, which are used to handle categorical data. So these are the main two categories of the data structures. Understanding these classifications help us to know when to use which structure depending on the type and the format of the data we are working with. So let's move to the vectors. A vector is the simplest and most common data structure in R. It contains elements of the same type. It will be numeric, character, or logical. So vectors are created using the combine function, which is called as C and parentheses. So a vector is simply a sequence of elements that are all of the same type, such as all numbers or all characters. Vectors are one dimensional. It will be in the form of rows or column. For example, here is the example of a vector. Here is one more example with names is equal to C and inside quotes text. So this is a string vector, a vector of strings. Okay, the first one is a vector of numeric values and the second one is a vector of strings because I am storing a text data in it. Next is the matrix. A matrix is a two-dimensional data structure. In matrix, all elements must be of the same data type. It has rows and columns. It can be created using the function matrix. Okay. So here it is the example. I am defining a matrix named M is equal to matrix function. I am calling a matrix function and then inside parentheses a sequence of 1 to 6, 1 colon 6 comma n rows is equal to 2. It's mean that I need 2 rows comma n col is equal to 3. There are total 6 values out of which I need 2 rows and 3 columns. So this create a matrix of 2 rows and 3 columns. Remember that matrices are very useful in mathematical calculations. So next is the array. An array can store data into 2 or more dimensions. All elements must be of the same type. Useful for storing multi-dimensional data. An array can be created using the array function. Similarly, I will write a is equal to array function and then I am generating a sequence of 1 to 12 and then I am defining dimensional. Okay, so it is a 3-dimensional in which I am defining dem is equal to C. Then again this is a combined function, then 2 comma 3 comma 2. Okay, and parenthesis closed. So this create a 3D array with 2 rows, 3 columns and 2 layers. Arrays are especially useful when you are dealing with things like image data or scientific simulations. Now we move to more flexible structure, the list. A list can contain different types of elements. So you can have number, text, vectors, even other lists all stored in one place. Here is an example. So I'm using list function and then I am putting our numeric value and then a string and then a combination of numeric values. Okay. So this creates a list with a number, a string and a vector. Lists are great when you want to bundle different types of data together. Next is the data frame. A data frame is like a table or separate sheet. It stores data in rows and columns. Each column can have a different types of data. Okay, it can be created using the data.frame function. Here it is the example. df stands for data frame is equal to data dot frame, and then I am defining a two vector inside one data frame. One is name, that is the string, and second is the ages. Okay, what makes a data frame unique is that each column can be of different types. In our case, first column is of name and the second column is of age, so both are different. First is the string column and second is the numeric column. So data frame are perfect for real world, and we use them all the time in analysis, visualization and modeling. So let's quickly summarize what we have learned today. First, vectors are one dimensional and contains elements of the same type, and then the matrices are two dimensional with the same data type, and then arrays extend this to the multiple dimensions, and then the list can hold different types of data, and then the data frames are like tables with columns of mixed types. So each of these structure has its own role, and understanding them help us to use R more effectively and efficiently. That's all for today's video. I hope you now have a clear understanding of data structures in R. If you found this video helpful, don't forget to like the video and subscribe the channel and hit the bell icon so you can never miss an update from this channel. See you in the next video.